Hello and good afternoon. This is an exercise in trigonometric and hyperbolic functions of the scholarship level. And we want to find an expression for the modulus of cos x plus iy all squared in terms of trigonometric and hyperbolic functions, and then show that the magnitude of cos x plus ix all squared increases with x when x is greater than 0. So first of all, just note, and we get these from the basic definitions of sine, cos, hyperbolic sine, hyperbolic cosine, that cosh ix equals cos x, sinh ix equals I sine x, cos ix equals cosh x, and sine ix equals I sinh x. Okay, so let's start. Right, we have cos x plus iy in bars squared, and that's equal to cos x plus iy times the conjugate of cos x plus iy. That's from basic complex number theory. And expanding each term, we get cos x cos iy minus sine x times sine y, and all of that multiplied by the conjugate. And then that's equal to cos x cosh y minus I sine x sinh y times cos x cosh y plus I sine x sinh y. Okay? And then multiplying out, we will get cos squared x plus cosh squared y plus sine squared x times sinh squared y. Now this does the trick, but improving that, we can write cos squared x is 1 minus sine squared x, and cosh squared y is 1 plus sinh squared y. And then we have the other term, sine squared x sinh squared y. And then multiplying that out, we get 1 plus sinh squared y minus sine squared x sinh squared y plus sine squared x sinh squared y, which simplifies to cos squared x plus sinh squared y, or equivalently cos squared y minus sine squared x. So that does the first bit. For the second, to find or to prove that the modulus of cos x plus ix all squared will be an increasing function. We notice that from what we've just proved, that function equals cos squared x plus sinh squared x. And so differentiating with respect to x, we get minus 2 sine x cos x plus 2 sinh x cosh x, which is, writing the positive term first, sinh 2x minus sine 2x, and that's greater than 0 when x is greater than 0. So f of x increases with x when x is greater than 0. Now to prove that claim, where I put a star, all you have to do is write down the Maclaurin expansions for the two expressions. Like sine 2x is 2x minus 2x all cubed over 3 factorial plus 2x to the fifth over 5 factorial, and sinh x is very similar, except all the terms are positive. And so from that, it's fairly obvious that sinh 2x is greater than sine 2x when x is greater than 0. And that does it. And thanks very much for listening.